वो केस गया सो नहीं वो केस गया सो नहीं पेपर अभी जोड़ के दिया है मैंने क्या पेपर जोड़ के दिया वो पर छोड़ दो उनका लिंक को ऊपर
Hello, good morning. Good morning, my dear students. This is Dr. Syed from DBS Institute of Technology. Today we are going to discuss about machine tool alignment tests. This is unit number 3, machine alignment. Machine tool metrology. The alignment test on a machine tool is carried out to check the grade of manufacturing accuracy of the machine tool. The geometrical checks made on machine tools are straightness and flatness of gateways and slideways of machine tools, flatness of machine tables, parallelism, equidistance and alignment of the slideways, true running and alignment of shaft and spindle. Then lead of lead screw or error in pitch. The geometrical test is carried out to check the grade of manufacturing accuracy of the machine tool. Practical test is carried out to check the accuracy of the finished components. Geometrical test consists of checking the relationship between various machine elements when the machine tool is idle. Practical tests consist of preparing the actual test jobs on the machine and checking the accuracy of the job produced. Static tests, dynamic tests. Importance of alignment test. The geometry of various shapes is based on the relative motion between various machine parts and hands-on alignment of various parts. Other parameters subjected to tests are So static tests, dynamic tests, the importance of alignment test. The geometry of various shapes is based on the relative motion between various machine parts and hence on alignment of various parts. Other parameters subjected to tests are stiffness and rigidity of the machine tool and its components parts, the quality and accuracy of the control devices and the drive mechanism. All these things we can do it. Alignment test on pillar type drilling machine. For example, now we are going to do an alignment test on a pillar drilling machine. Now you can see the right side there is a machine, pillar drilling machine. In this pillar drilling machine, at the bottom you can see base block. At a vertical a pillar is there. Over the pillar there are over this pillar there is a drill gate is there, where this gate is consists of a screw. When the screw moves, then the table will move up and down. Then you can see here there is a center distance between the drill center to the pillar. Then there is a spindle sleeve. Then drill head gate is also there. So these are some of the parts of the drilling machine. Now we will see how we are going to do the alignment test. You should properly install the drilling machine in both horizontal transfer direction and vertical directions. So align first the alignment. Then flatness of clamping surfaces of base. So when you clamp any job over the table or base, it should be very flat and horizontal. So straight edge on two gauges blocks, that is straight edge on two gauges blocks is used here. You can take a feeler gauge and we can check up the error. Error should not exceed 0.1 by 1000 and 1 by 1000 of a millimeter. That is a clamping surface. Surface should be concave only. Flatness of clamping surfaces of table. Perpendicularity of drill head gate to the base plate. So perpendicularity of the drill head gate to the base plate. It is tested in both vertical plane and in a plane at 90 degrees to the above plane B. The frame level with graduations from 0.03 to 0.05 millimeter. Frame level will be between this. Error should not exceed 0.25 thousandths millimeter pi and 0.15 per thousand for B. Perpendicularity of drill head gate with table. So perpendicular of the drill head, gate with the table. The drill head should be exactly 90 degrees and with a little error of that is frame level will be 0.03 to 0.05 and the error should not exceed 0.25 by 1000 for A and 0.15 per thousand for B. Then perpendicularity of spindle sleeve with base plate. This is tested both the planes using frame level. Error should not exceed 0.25 per thousand millimeters for plane A and 0.15 per thousand millimeter for plane B. Number 6, true running of spindle taper. Now you can see here, there is a table. On the table, a dial indicator has been kept, and you can see here in the spindle, check spindle, we will fix a mandrel. We will fix a mandrel. This mandrel consists of a taper shanks which goes and get seated inside the mandrel. And when you rotate this mandrel, the dial indicator will show any error. If there is an error, it will show some error, or otherwise it will show only 0. If 0 means it's perfectly correct. But of course, always it won't be 0, but there will be generally some error will be there. So test mandrel is placed in the tapered hole of a spindle. Dial indicator is fixed on the table. The spindle is rotated slowly. Error should not exceed 0.03 per 100 millimeter. Per 100, 0.03 error may be there, should not exceed. For machines with taper up to Morse, and its taper is always Morse taper. Number 2, 0.04 per 300 millimeters. Per 300 millimeters for machines with taper larger than Morse taper. Number 2. So like this, we'll have to check up the drilling machine mandrel. Number 7. One is we have rotated the drilling machine spindle and we have checked is there any error is there or not. And now we'll have to check out the parallelism of the spindle axis with its vertical movement, because when you are drilling a hole, the spindle will move vertically down and up. If it is not moving exactly at 90 degrees, we will get a hole at an angle. If it is at 90 degrees, we will get a 90 degrees hole. Test is performed into two planes A and B. Test mandrel and a dial indicator. Here you can see on the table there is a dial indicator. This dial indicator is in contact with the mandrel. When you move this mandrel up and down, if the dial indicator shows any error, it means there is an error in the vertical movement of the mandrel, vertical movement of the spindle. So we will get wrong hole. Of course, there will be some error which is allowed. The permissible error is for machine with taper up to Morse number 2 is 0.3 per 100 millimeters for plane A, 0.03 per 100 millimeters for B. So this error is allowed. For machine with taper larger than Morse taper number 20.05 per 300 millimeters. For plane A, 0.05 per 300 millimeters for plane B. So if it is like this, we can allow it. Now, squareness of clamping surface of table to its axis. So till now we inspected the rotating mandrel. The rotating mandrel, when the mandrel rotates, you have seen is there any out in the mandrel, or rather the moment of the vertical and down moment of the mandrel is having any errors. Now we are going to check up your the surface where you are going to fix the job. So this table or the base, whatever it may be, we'll have to check both. So now here we are checking the squareness clamping surface table to its axis. So this is in this way, that is, a dial indicator is fixed in the mandrel. Table is slowly rotated. So we can move the table, we can rotate the table slowly. Error should not exceed 0.05 per 300 millimeters diameter. Error should not exceed 0.05 to 300 millimeter diameter. So when you move the table, if the table is somewhere right side up, left side down, something like this, it will show you the error. Suppose if it is like that, again the hole which you drilled, it will go to in a certain angle. Squareness of spindle axis with table. Straight edge placed in position AA. Straight edge. Take a straight edge. Take a straight edge and keep it on the table. Work table in middle position of its vertical travel. We can keep a dial indicator which is fixed in the mandrel, and the mandrel is fixed in the shaft. So we can see here plan XS. Plan XX, it shows there is A, B, B. So AA is 180 degrees, B1 is 180 degrees. The permissible errors are 0.08 per 300 millimeters for AA. Permissible error are 0.08 per 300 millimeters for AA and 0.05 per 300 for permissible error for B1. Suppose if you check the left side, that is B1, which is the error may be 0.05 per 300. If it is AA, the error may be 0.08 per 300. Like this, we can check with the straight edge. Now we can see what is the deflection in this machine. So this drill head and the table are arranged in their middle position. First, the drill head and table are arranged in their middle position. Then we are going to fix a dial indicator. You can see the dial indicator is uplifted on the top. And the top, that is drill head. It is touching to the drill head. Then under this one, dynamometer will be there. This dynamometer will rotate. When it rotates, we can see the deflections in the dial gauge. So here some examples as given. Drilling diameter in open hearth steel. See, drilling diameter, it is a steel. The diameter, if diameter it is 6, maybe 6 inches, 6. If it is 6, and then you will get 100 deflection, you will get 100 deflection. If it is 10, you will get 200 deflection. Like that, we'll have different deflections. It depends on the diameter of the drill which you are drilling. Now we can see how you are inspecting a drilling machine and what you are inspecting. See, we have seen three setups. Dial indicator which has been kept on the table and we have rotated the spindle, and dial indicator we have kept on the table and we have moved the spindle up and down and find out the verticality of the spindle. Finally, another one, we have found out the deflection by the dynamometer and a gauge. So, drilling machine can be checked for all these three. If all these three are quite okay, then we can say that this drilling machine is perfectly okay. You can use this drilling machine. So, whenever you get any new drilling machine, you will have to do all these inspections. As an engineer, you are responsible to check all these things. Otherwise, whatever the job you work on these drilling machines, the holes may not come perfectly as per their size, or they may not come exactly in a vertical way. There may be somewhat little defects. To avoid all these defects, we'll have to inspect the machine perfectly. I hope you understood well about this drilling machine inspection. And if you have any doubts, you can ask me, please. Now, this topic is finished. It's time over. Thanking you very much.